For our group assignment, our question is, express fx equals to modulus 1 minus x plus 2x as a piecewise function. Hence, find the f inverse and its domain. Sketch f and f inverse on the same axes. A piecewise function is a function which is defined by different expressions for different parts of its domain. Absolute values of linear function is defined by. So for this question, we can write this function in that format. Write the equation in the modulus first. 1 minus x if 1 minus x is greater and equal than 0. Next, negative 1 minus x in brackets if 1 minus x is less than 0. Solve the equation, and then we get 1 minus x if x is lesser and equal to 1. And negative 1 plus x if x is greater than 1. Next, we have to add in 2x into both equations. Hence, we get 1 plus x if x is lesser and equals to 1, and negative 1 plus 3x if x is greater than 1.
The question asks us to inverse the function. First, we separate the function into two parts. When we open the modulus, the first part of the function is fx equal to 1 minus x plus 2x. Solve this first. To find the inverse of this function, first, we let inverse function of x equal to y and function of y equal to x. 1 plus y equal to x. Now, rearrange the equation to find y in terms of x. Hence, the first part of the inverse function is. After opening the modulus, the second part of the function is fx equal to negative bracket 1 minus x plus 2x. Let the inverse function of x equal to y and function of y equal to x. 3y minus 1 equal to x. Now, rearrange the equation to find y in terms of x. Hence, the second part of the inverse function is. By using the properties of inverse function, the domain of an inverse function is the range of the original function, and the range of an inverse function is the domain of an original. The range of the original function for x plus 1 is. Hence, the domain for the inverse function is. That goes the same for the domain of the second part of the function, which is 3x minus 1. The range of the original function is. Hence, the domain for its inverse is.
The piecewise function that we get is 1 minus x for x less or equal to 1, and negative 1 plus x for x greater than 1. These are linear functions which are straight line on the graph. For x plus 1, we can compare it to the equation of a straight line, y equal to mx plus c, and we get that y-intercept is 1. Since the gradient is positive, the graph will ascend. For the x-intercept, we will get negative 1 by substitute y equal to 0 into y equal to x plus 1. For function 3x minus 1, x is greater than 1. Since it has the greater gradient than x plus 1, the straight line will become like this. This is a function fx. Before reflecting out the inverse graph, we must draw line y equal to x as the axis of symmetry. For inverse function, we have x minus 1 if x less than equal to 2, and x plus 1 over 3 if x is greater than 2. The first part of the inverse graph, x minus 1 if x less than equal to 2 reflected out will look like this. While for the second part of the inverse graph, x plus 1 over 3 if x is greater than 2 will reflected out like this. From the inverse graph, we got that x-intercept is 1 and y-intercept is negative 1. This is the inverse function of fx. As you can see, the function of fx is switched to its inverse function by being reflected out in line y equal to x.